before I get into the AIS lenses that I'm using, I thought it would be useful to show you how these lenses can actually help you with working out how to do focus, how much depth of field you get on the lens, and how to use it. So I've tried to model one of my lenses, which is actually the 28mm AIS 3.5 lens here. What you can see is basically two rings of numbers. One is the focus ring and the other is the aperture ring. Both of those revolve around the silver ring with the spot. If we look at the lens, and in this model I've chosen f11, you can see that the aperture ring actually has different colors for each of the aperture numbers, and they correspond to the score marks that are either side of the black spot. So if we look at number 1, I've chosen f11, and we see that actually that's yellow, and we've got two score marks in yellow either side of the black spot. Now, by using that, we are able to decide where the depth of field is positioned in terms of focus. So if we take the infinity marker, that's the 8 on its side, and throw that to the left-hand side of those two score marks in yellow, then we can see what we get from the right-hand side to see what the nearest is that we would focus. In this case, we can do about infinity to about 1.5 meters. That basically means that when we can get away with f11, that we can actually set this lens to be effectively a fixed focus lens from about 1.5 meters to infinity. And that means we don't really have to worry very much about focus under these circumstances. Obviously, we need to deal with ISO and we need to deal with shutter speed to cope with whatever aperture that we've chosen. But that can be done because you can see on the lens what is possible and then adjust everything accordingly. On this slide I've done a comparison to show you what one would see on one of the more modern lenses. This is a 35mm f1.8 AFS lens, and while the infinity marker is not quite as big as it actually is on the lens, the f16 is the only thing that's marked on this lens, and you can see that they're so close together and the scale is so sparse in information that to try and use that to determine the depth of field of this lens is impossible. You're pretty much down to trial and error, and you are certainly not in a position to be able to assess what type of properties the lens has before you buy it. A final note, which I cannot be 100% sure on, but certainly it looks as if the modern lenses position the focus point to be the left-hand side of the infinity marker and not the middle as with the older lenses. This of course does have an effect in terms of how much would be in focus using the depth of field if you were to use the visual representation. So these lenses give you much more information about the optical properties, how much depth of field and what choices are open to you than the modern lenses. The modern lenses give far too little information and you almost have to rely upon the automation, and you're not able to take control easily yourself.